Hello. Let's start. Today we're going to talk about recursion. This is very interesting topic because I think it's the most, it's hardest thing to understand when you're new in programming, because it's don't fit inside a brain. It's sometimes when you try and imagine recursion, your brain is don't want to let you understand it. So what is recursion? Basically, recursion happens when we have a method that calls itself. This is the recursion. So we have a method func, and inside this method we have a call to method func, and that's it. This is basically recursion. So I think to better understand what is recursion is, I think you all saw memes about recursion, because it's easy to create such a meme. You just create something that goes infinite, and this is funny meme about recursion. Also, one example of some sort of recursion is a fractals, and fractal is a pattern that repeats itself. So we have fractals in nature. For example, this trippy cabbage. I don't remember how it's called, but it's basically repeats its shape over and over again. And we have such fractals. It's called Mandelbrot set. And this is very simple mathematical concept when we use a simple, we can say, algorithm to have such infinite visualization. But we change only the zooming of this structure, but all of these forms are created by a simple mathematical rule. So what else? One more example of recursion. It's when you when you share your screen and you open this tab that in which you share your screen, and you have this infinite loop. It's sort of recursion because you recursively share your screen. Is this, are you with me? Is this understandable? It's just a little example for fun. So let's move to actual code. Let's create a recursive method. So let's it with void without any argument, and let's print there something. Oh, thank you, Sergey. Let's print this, and let's call this method, and let's call it from the main. What will happen when I will try to run this code? Yeah, it's right. We will have an exception, Stack Overflow. And what will happen before we will have Stack Overflow? Yeah, maybe. Let's try. so many errors, and I think at some point we have Stack Overflow. Yeah, and we can even modify it a little bit to see better how many times we can call this method before Stack Overflow. So we can pass in this method some variable and pass recursively the index that bigger that we will increment. So now, and also now, if we will run our program, we will have very similar thing, but you can see that we had 5,000 and so on calls before Stack Overflow. So can someone explain me what is Stack Overflow? What does it mean? Yeah.
Stack works in the algorithm that the first put in, the first get out.
Mm-hmm.
So we, when we don't get out our information out of stack, it just increases, and it goes up to the maximum value and just gives an error.
Okay, yeah, basically it's right. And now I will try to explain this concept for everyone. So when our program executes some method, what happens under the hood? When some method is called, for example, we start from the method main. When we start from the method main, we have such thing as a call stack. And it's happened when your program is running. You don't see this, but it happens under the hood. So we have this stack. So the compiler says, now I'm executing method main, and it's at. Let's imagine that our books, it's our methods. So this is our method main, and compiler starting to read our method line by line and do some whatever it's want it to do, and it's going line by line. And when it's done, when method main is done, and we like at the point when compiler don't need to do anything else, it's remove this method from the call stack. So let's imagine we have method main and some operations, and then we have, for example, call for some method func1, and then we have another operations. So in this case, we add to call stack our method main. Compiler go line by line, like check this line. For example, it's print, something to print. Then this line, something to calculate. Okay. Then we can see this line. It's in this line saying you need to execute this function, another method. So our system saying, okay, basically I need another method at that point. So I will add some bookmark at this page where I stopped, and I will add another method method func1 to this call stack. And I have actually an example, the code example for this situation. So we have a method main that prints something, then calls a method A. So we call in method A. Our system saying, okay, I need to add method A. Now our system is reading this method A, and we can see that it must print A start. Okay, we printed it, and then we see that we need to call method B. So our compiler adding a bookmark to remember where to return, and adds method B, and it starts to execute this, and it's print start B, and then it see, okay, I need to execute method C. So it adds another bookmark and adds another method C. In here, we can see that, okay, I need to print C start, print it. Then, next page, I need to print C end. Okay, I printed, and I ended this method. So what does it mean? When I ended this method, as a system, I remove this method C from this call stack, and I am returned to this bookmark. Because when we create a new method in call stack, this stack instance, we can say, have information about method name, parameters that passed in this method, and also an address of place where we need to return when this method is ended. To continue this analogy, like the page number. So this call entity, stack entity, is know the page where it needs to go when it's done. So we done method C, and we continue from our bookmark. We go next, print B end, and this method also ended. So we do what? Yeah, we remove it from the stack. We go here to this bookmark. We print A. What we do? Remove from the stack. And we now in our main method, the same thing. We remove this bookmark, we print main end, and we remove from the stack our main method. And when our call stack is empty, it means that our program is done, is ended. So this is it. Maybe someone have questions about this. We will come back to call stack later, so you can like store this. You can remember your questions. So what does happen when we do a recursive? What's the theme of our lecture? So what happened when we call a method inside method? So we have our main. We call func method. So we add it on our call stack. We print func call number index, and then we do the same operation. We call func again. So we add func again. Print, call func again. Print, call func again. Print, call func again. I didn't have capacity. I could bring a whole library here, and I could. It's infinite, yeah. And at some point, your table will like break under the.
Break the floor and the itself too.
Yeah.
I think we have enough books.
Yeah, and to continue this analogy to our like system, when system creates this call stack, it allocates some memory that it can use for storing information about those methods. It's not infinite storage. So when we reach this limit of memory that we can use to store our like call stack, our call entities, we have an exception that called stack overflow, because our call stack is overflowed. Is this understandable?
Well, it's quite clear to know that it's overflows, that it's just like overcrowded, overwhelmed.
Yeah, 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 something like this. What?
It's like overwhelmed.
I don't know, Sergey, what do you think? Overwhelmed is the right way to say.
Overwhelmed or overflow.
Yeah,
So
yeah, looks like this, yeah. So, what to do to not have such Stack Overflow exception? We can create such things that called base case. And it's very important in recursive calls. So we can just add some check. If our index is bigger than 100, we will, we don't need it actually, we will stop our program. And now what we will have in our console? Yeah. What 101, but we can add like yeah, or just equals. Yeah, yeah, for example. And this is called base case. There is some base case that ends our recursion, because the nature of recursion is to be infinite, and we don't want it to be infinite. So let's move to some example. Do you know what is factorial? So for example, 5 factorial. Plus? Yeah. So basically, this part, 4 multiplied by 3 multiplied by 2 multiplied by 1, what is this? Yeah, it's 4 factorial. And 4 factorial is basically 5 minus 1 factorial, right? So we can say that 5 factorial equals 5 multiplied by 5 minus 1 factorial, right? And if we will create a function for this, that will have parameter, for example, x. This looks understandable. So we have such concept that 5 factorial, it's 5 multiplied by 5 minus 1 factorial. And if factorial is a function, so you're all familiar with this concept from the math functions, and this is the same thing that functions in programming, basically. So if we have a factorial from n, how I can represent it using this structure? Yeah. So if we have function factorial, we can write our function like this. And this looks understandable or no? Please raise your hands who don't understand why.
Could you elaborate on n factorial, where it's n multiplied by n minus 1 and factorial? Like how is it, why is it just a formula? Because I don't, on the right.
Yeah, so you can see here that basically, if we will split our factorial representation, this part is basically also factorial, but for numbers that less than biggest. So let's talk about this. Will it work?
No.
Why?
It will go to 0.
At some point, yeah, it will break.
Why?
We don't have a stop. Yeah.
We don't have if x equals 1.
Yeah. Okay. What we need to write if?
Return 1.
Okay. Will it work now? Okay. Someone, do you understand? Okay, this is not right question. I get it. Let's create a trace for this factorial recursion, because when you will try to pass your assignments, I will ask you to write a trace for your recursive methods. So let's imagine that we have our main method, and we want to have our value. We want factorial factorial of 5, and as you already know, when we have such code, when we say that value equals to function, basically we can see the type that our function returns, and when we write something like this, it's I can compare it with some a contract. Like I'm saying, you will have your value variable when this function will be finished. So right now, I can give you only like a paper representation. I can give you a contract, signed contract that I will give you this value, but not right now. So basically, when factorial of 5, this function, will be finished, when we hit our return point, we will have some value here. But right now, we don't have it. So we call this method. We go here, we check x, we have 5 here, x equals 1, no. Then return x equals factorial x minus 1. What does it mean? We will have in this place something that looks like 5 equals factorial of 4 because x minus 1, right? Then we go here, we will have some number, and when we will have this number, we could multiply it by 5 and return to the value. And once and for all, value will have its value, its factorial value. So we have call for factorial 4. We go in factorial. Now it's x equals 4. Is x equals 1? No. Then we return this value. So now this looks like this, and so on. And so forth. And then we have factorial from 1. And what will happen? We check our x now equals 1, and this means that we return 1. So this means that we will return 1, and we can place, we can change our factorial 1 with number 1. Do you understand why? Yeah. Maybe someone don't understand why we can change our factorial 1 with number 1. Okay, so one more time. Our method is like a contract. I'm obliged is a word, to return some value in the place where I call the method that needs to return some int. So when I call this factorial 1, I basically run this code. And this code says that when x is 1, we will return int 1. So return means that we can place замість instead of this factorial 1, 1. So now we have 2 multiplied by 1. So we can change our factorial 2 with 2 multiplied by 1, and here we have multiplied by 3. And this means that this factorial 3 we can change with 3 multiplied by 2 multiplied by 1, and we already had 4. And this means that factorial 4 we can change with this number. So this is basically already some number, but I show you this process just for your information. Basically, this factorial 4 is not 4 multiplied by 3 multiplied by 2. This is basically, what, 24, right? But I use such writing for your like better understanding. So, and what at the end? We can change our factorial 5 by 5, 4, 3, 2, and 1. And now our method stack is cleared, and we can go on to print, for example, our value. Because this line print not going to be executed while we in this call stack, because at this point our program is like stopped on the pause in this scope, and it's working with those methods that in this call stack. And when we back to our main, we can go on and read other pages and do other stuff. Any questions about this? Okay, let's move on. One more example. I need your help. I want to write in my console such output. I saw in previous lectures that Sergey used word BAM, but I think не на часе. Maybe like Happy New Year, right? So, someone, please help me to write function to do this. Our function will call down, and let's let it be also void. Yeah. And so what I need to do?
Salt int. First of all, we need to check like if statement or something else. If int equals to 1, or let it make if int equals to 0. Print Happy New Year. And ready. Or else.
And return. Why? Yeah, right, because we need to finish it. Oh, this Java. Okay. Okay, what's next? Okay. So, will it work? No?
Like our method is void.
Yeah, it should. System out is not a variable.
Okay,
Yes.
it's work. So I also want to add one more print that will tell us about our current operation. So oh, this is so embarrassing. I don't know how to do it in Java on the Java course. Oh no. I will do it like this. Sorry, guys.
I mean, works.
Yeah, totally agree with you. So, let's see. Looks strange. Why? Why in such order? Let's
Because first it resolved the stack with the the actual operation,
yeah.
and when it kind of when all of it ended, it then like kind of threw out all the system outs.
Yeah, basically it's true. And to better understand this concept, let's create our call stack in such representation. So what we have? We have our main method. So we add this method. It's called main. We have its name. Also, we have parameters. Doesn't matter what parameters we have there. For example, empty array of strings. Then we call countdown for file. Let's. I don't. Okay. No, doesn't matter. We call countdown for 5. So we add this method, its name, and parameter that we pass. And we start to execute this method. So first of all, we check is count is equal 0, no. Then we print our variable. So let's imagine this is our console. We print our 5. And then we call once more our this method itself. So now we add it's one more. With 4. We check this, we print 4, and once more we call itself. Right? We print 3, we call itself. We print 2, we call itself. We print 1, and we call this method with parameter 0. And when count is 0, we print Happy New Year and return. What happens when we return? We ended our function, ended our method. So we remove this method from the call stack, right? And then we continue our method this cut down with parameter 1 at same point when we ended, when we started. So now we're here and we go to the next line and we print operation ended for what number? Yes. What number? 1. Yes. And then our method is finished totally. So we can remove this method from this call stack and in method cut down this parameter 2 where we started, where we ended, I don't know, at, on which line of code? Here, because we called method cut down 2 and we like провалились in this rabbit hole of recursion. Fell down, yeah, for our totally English viewers. We fell down totally in this rabbit hole. But now we are like trying to get out. And now we finished our method cut down 2. And we can move on and print operation ended. What number? What? 2. And when we printed this, we finished our method with operator 2. And we can remove it. And we can do it like one by one until, and we will have those prints until our cut down 5 is going to be executed, and we will like find ourselves in the main method. And when main method will end at 2, we can remove our main method from the call stack, and our program will be finished. Yeah. So, any question about recursion?
If we wanted to get like an accurate operation ended stuff, where would we put it? Would we put it anywhere? So before the countdown, I guess.
What do you mean?
Like here, our operation ended like sort of like failed.
Yeah.
It's not an accurate prediction. But how can we fix it?
Why it failed? Why it failed? It's not failed. It's did right job. No.
But we have it printed like after New Year, and we want kind of print it after 5, 4, 3, 2, 1.
And kind of in the correct order.
Oh, okay. So if you want to do it in a right way, I think this is a right way, because we can see when our operation ended. So it may be not pleasant to look at because they ended after New Year, but it's a reality of recursive method, because really this cut down operation ended when we have this output. But if we want, this is interesting question, because we can manipulate the order of our data, changing the basic thing. We can change the place of our print, if it's before our recursive call or after. And you can play with this, and I think you will have such opportunity now when you will have your assignment, classwork assignment. But before, maybe someone have another question about recursion. Maybe you notice that everything that we did with recursion we can do this with loops. Like, no problem. It will be even easier to understand to do this with loops. So I will ask this question like for you. Why we need recursion if we have loops? You can answer.
So sometimes we have such tasks like tutorials
Yeah.
when the next step is depends on the previous one.
Yeah.
So in these ways, it's more intuitive. It's more intuitively to use recursion.
Yeah.
So only in this way.
Yeah, I asked ChatGPT yesterday why we have recursion. Really, why? Because anything that we sometimes we have some tasks that can be done with loops, but can't be done with recursion. But we never have such operations that we can done with recursion and can done with loops, I think. So why we need recursion? First of all, we can create more compact, more good-looking code. Second of all, sometimes, like with factorials or with the trees, in next course, in next year, we will learn like different data structures, and one of them is trees, and traversing trees is very intuitive and very easy with recursive methods. It's only two lines of code, but you can traverse all this very like complex data structure. So basically you have like now you on these lectures we give you some instruments that you can use in your programming: fork, spoon, and this is for example a knife for cheese. Like, you're not going to use knife for cheese every day, but sometimes you will have cheese and you will like, oh, recursion, I can do this with recursion. It would be easy, it would be great for understanding for other programmers who will read my code. So it's just an instrument for you, and it's for you guys, it's great training for your brain, because it's hard. Recursion is hard to understand with human brain, but when you able to understand it, you like became closer to the computer, to the compiler. You became a compiler. So something like this. So if you don't have any questions, we can move on to the class assignment.
Let's decide now. So we already have 4 o'clock. Maybe I would propose maybe to make a picture of that and play with that by yourself. I don't think we have enough time for that to give you the class assignment.
Yeah.
So, yeah, but we recommend you to think about it, and when we check your homework, we could ask you to make some simple recursion task with us, just without any additional resources or AI. Just to solve that task for yourself during the assignment check. So this is one more reason why you maybe have sense to play with that.
Yeah, and I can guarantee you that you will have another tasks during your project checking. So they're not going to, but they may. So maybe we will ask one of those tasks, maybe something another. I don't know. You have 15 minutes. You can play with this right now without any points, but for better understanding. And I will be here, and you can call me I will go to you and you can ask me something if you want.